Hi guys, today we have a nice computational problem from the 2000 AIME 2. Given that this expression is equal to n over 18 factorial, find the greatest integer that is less than n over 100. Okay, so the first thing we want to notice is actually when we add the terms of the denominator, we get 19. And we also have 2 factorials in the denominator, which is kind of the form of n choose k. So we want to multiply by something so that we can maybe get some combinatorial terms and we can simplify the problem further. So since we have 2 terms that add up to 19, we're motivated to multiply by 19 factorial to get some chooses to further simplify this problem. So doing so gives us 19 factorial over 2 factorial times 17 factorial plus 19 factorial over 3 factorial times 16 factorial plus all the way until 19 factorial over 9 factorial times 10 factorial, and this is going to be equal to 19 factorial over 18 factorial is 19, so 19 and okay, great. So now let's do that strategy where we convert these into choose terms. We can write this as 19 choose 2, we can write this as 19 choose 3, and then we can write this until 19 choose 9, and this is 19n. Now, as a general tip, whenever you see like 2, 3, and then consecutive numbers, you want to think of this following identity. When we have n choose 0 plus n choose 1 plus all the way until n choose n, this is actually equal to 2 to the n. And a quick proof of this is simply considering the expansion of 1 plus 1 raised to the power of n. Applying the binomial theorem will indeed give us the sum of these binomial coefficients, which we can just evaluate 1 plus 1 equals 2 to the n. Alright, so now we want to kind of apply this to our problem over here. So let's see how we can do that. Okay, so we have 19 choose 2 plus 19 choose 3 all the way until 19 choose 9, and we calculated that as 19n. That's 19n. Okay, so now let's formulate a similar expression so that we can utilize this. So we know that 19 choose 9 is nothing but 19 choose 10. In general, n choose k is nothing but n choose n minus k, and we can see that pretty intuitively. Let's see. 19 choose 8 will be nothing but 19 choose 11, all the way until we have the 19 choose 16, and then 19 choose 17, and then this will just be 19n. Now let's add them together. We have every term from 19 choose 2 up till 19 choose 17, and then adding them 38n. So now the only thing we're missing to utilize this fact is 19 choose 0, 19 choose 1, 19 choose 18, and 19 choose 19. So we can write this as 2 to the power of 19 minus 19 choose 0 plus 19 choose 1 plus 19 choose 18 plus 19 choose 19 as such. So we're just having the 2 to the power 19, and then these are the terms that we still need. Okay, so evaluating this, we quickly get 40. So 2 to the 19 is equal to 38n plus 40. So we can divide by 2 to get that 2 to the 18 is equal to 19n plus 20. So let's solve further. So we know that 19n is therefore equal to 2 to the power of 18 minus 20. And if we go back, the problem wants the greatest integer that is less than n over 100. So I didn't see any slick way to do this further, so I just manually calculated this. It's good to remember your powers of 2 until like at least 20. So let's do this. We have 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16384, 32768, 65536, 131,072, 262,144, minus 20, which gives us 262,124. So 19n is this number. So all we have to do now, I guess we can go to a different page, is calculate n, and then we can calculate n over 100 from there. So 262,124 divided by 19. Doing this calculation, we get 11972, 357, 15, 1. That goes in 7 times. 763, that's 133 with 18 left over. And then 9, 90, 81, 171, 114, and that goes in 6 times. So n is nothing but 13796, and then we want the least integer that is, let me just see. We want the greatest integer that is less than n over 100. So n over 100 is equal to 137.96. Taking the greatest integer that's left in this is just 137, and we are done.